Okay, this problem says a boy throws a ball of mass 0.25 kg straight upward with an initial speed of 20 meters per second. When the ball returns to the boy, its speed is 17 meters per second. How much work does air resistance do on the ball during its flight? Okay, so here's the ball, he throws it straight up, and then it comes back. Okay, so the initial velocity was 20 meters per second, and the final velocity is 17 meters per second. I'm writing speeds, so the initial speed is 20 meters per second, and the final speed is 17 meters per second. All right. When the ball is in flight, during its entire flight, there are only two forces acting on it. Air resistance and gravity. Okay. So when it's falling down, gravity is in this direction. Okay, this diagram is getting messy. Okay, I'll draw it separately. So when it's going up, here's the force of gravity and here's the drag force. And when it's falling down, there's the force of gravity and there is the drag force. Okay. So, but the point is there are only two forces acting on it through its entire motion. And we will use the work energy theorem. The net work done is the work done by all the forces acting on it. Work done by gravity plus work done by what kind of force is a drag force? It's a friction force, and that is equal to change in kinetic energy. Okay. Now change in kinetic energy is easy to do because you're given the final speed and the initial speed, so this is given. Okay. Now they're asking you to calculate the work done by friction force, so this is given. If you want to calculate that, you need to know this. But what kind of force is gravity? Right.
Conservative force.
It's a conservative force. And the work done by it's a very special force, and the work done by gravity is this change in gravitational potential energy. U final minus U initial. Mg final, Y final minus Mgy initial. Again, that's how you calculate the gravitational potential energy, change in gravitational potential energy. And how much gravitational potential energy changed when the ball went up and down? It came back to the same level. Okay, so the change in gravitational potential energy is 0. So 0 plus Wf equal to okay. So that's why they didn't tell you how far up the ball rose, but we didn't need that. Okay. All right, so let's do the numbers now. 1/2 m Vf square minus Vi square. 1/2 0.25 kg times 17 square minus 20 square, and meter square plus second square. Okay. Okay, so work done by friction is, that works out to negative 13.9 joules. Okay, and we know that friction drag always does negative work. Okay, so we got a negative work done by the friction force. Okay, so you guys understand? Again, in this problem we have used the work energy theorem. The work energy theorem says the work done by all the forces acting on the object shows up as change in kinetic energy of the object. And there were only two forces acting on it, drag and gravity. And the work done by gravity is just change in potential energy. Here, in this problem, it happens to be 0. Yep. Yep.
What does the Y stand for again in the change of potential energy equation?
The vertical position, the Y coordinate, there's the Y coordinate.
Okay, got it. So the height.
Right. From a reference level. Okay. All right. Any other questions before we stop this problem? Yep.
Why did it end up doing 2?
So the problem says straight when the ball returns to the boy, he throws it up and it comes back to his hand. So the initial and final location, Y coordinate of the ball are the same.